All right, class, the last section that we're going to look at in Chapter 8 is Section 8.8. And we're going to use today to be able to tell the difference and distinguish between linear and quadratic functions. Okay, so let's go up here and look at my first example on the board. It says the function g, remember functions have a name, this one's name is g, is defined by g of x equals 2x minus 3, is called a linear function. And it says y. Now, does that g of x, does this look really close to something that we've kind of been working with? Yeah, good job. That looks like slope-intercept form. G of x is just a fancy way of saying y. So this really looks like slope-intercept form. Y equals mx plus b. So we've seen that over and over again that we've been in Chapter 8. So y is called a linear function. Why? What did we learn back on that reading quiz? Why is it called a linear function? Yeah, great job. Because its graph is a line. That's what we learned, okay? Now, let's see what happens if I do a little input-output chart as I look here at my first function. So, linear function, you can recognize it because it looks a lot like y equals mx plus b. So look at my input-output chart. If you notice, my x's are my range, okay? My range, my R didn't work there. Okay, so let's plug in 0. If we plug in 0, let's get rid of some of this here. If we plug in 0 into my function, well, if we plug in a 0 here, we get 0 minus 3, which is negative 3. Well, let's go ahead and let's plug in a 3. Remember when we did the point plotting method, we usually plugged in a negative number, 0, and a positive number. So what happens if we plug in a 3? Well, we're going to have 6 minus 3, which is 3. And then for our negative number, let's just go ahead and use negative 3. So we've got negative 6 minus 3, which is negative 9. Okay, so we used our function and we plugged it in and we got our, these are our domain values, our x's, and then we got our y's are our range. And then if we take these 3 ordered pairs here and we plot them, you notice there's my graph. My graph is a line, okay? So, okay, Miss Burton, we've been doing that for a while. I think I got that. Now, let's see what happens if I give you a different function. Let's say I give you function h, and I say graph the function h defined by the equation. Well, remember, h of x is a fancy way of saying y. So let's go ahead and do an input-output chart with these numbers here. Now, let's see what happens when we plug in a negative 2. Well, we're going to get what? Negative 2 squared minus 2 times negative 2 minus 2. All right, so what's that going to give me when we go through there? We've got 4 plus 4 minus 2. 4 plus 4 minus 2 is 6. Okay, now let's go ahead and let's do every x in our input-output chart. What happens if we plug in a negative 1? Well, negative 1 squared is 1. Negative 1 times negative nu is positive 2 minus 2. So if we do the math when we get through there, we're going to get a 1. What happens if we plug a 0 in? Well, if I plug in a 0, we've got 0 minus 0 minus 2. So that gives me negative 2 in my input-output chart. All right, what happens when we plug in a 1? If we plug in a 1, we've got 1 squared, which is 1, minus 2 minus 2. So when I plug in the 1, what happens? Well, 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. Okay, what's the next number in our input-output chart? We're going to plug in a 2. So we've got 2 squared, which is 4, minus 4 minus 2. So 4 minus 4, okay, and so that's going to give me negative 2. What happens when we plug in the 3? Well, when I plug in the 3, we've got 9 minus 6 minus 2. That's going to give me a 1. And when I plug in 4, last number in my input-output chart, when we plug in a 4, we've got 16 minus 8 minus 2. And so I think that's going to give me 6. Did I do that right? Okay, so we took our function and we plugged in our domain to get the range. Now, what would happen if we graph this? What graph is this going to look like? So let's go ahead. You can use your graph paper, and let's graph these points that we just found with our domain and range from our input-output chart, and let's see what kind of graph we get. So negative 2, 6, left 2, up 6, so that puts me about right there. We're at negative 1, 1, left 1, up 1. We're at 0, negative 2, so stay at the origin and go down 2. We're at 1, negative 3, so we're at right 1, down 3. 2, negative 2, and then we've got 3, 1, and we've got 4, 6. So if you look, definitely not a straight line this time. What happens if we connect the dots? If we connect the dots and we go down through here, oh, look, our graph looks like a U, okay? And this type of graph is called a parabola, okay? The curved graph is called the parabola. Now, we need to notice some things about the parabola, okay? Now, we're going to see at the very bottom down here, the lowest point, okay, that lowest point is called the minimum, okay? So my parabola went up, okay? And when my parabola goes up, that lowest point is the minimum. And so the lowest point is 1, negative 3. Now, we're going to see that's also known as my vertex of the parabola. Okay, the vertex of the parabola. Okay, now that vertex tells me two things. Okay, if you notice, this parabola has an axis of symmetry, and the axis of symmetry goes right through, there it is, goes right through, there, close enough, goes right through the vertex, okay? And so when I look here, the x value of my vertex gives me my axis of symmetry. And again, what does symmetry mean? We've seen that a lot in math, a little bit in math, a lot in science. Yeah, if I graphed this parabola on a piece of paper and I folded it down the purple line, the red parts would be mirror images of each other. So the vertex, the minimum, which is my vertex, okay, the first thing it tells me is it tells me my axis of symmetry. And because it's a vertical line, remember vertical line is x equals some number. The second thing that it tells me is this idea called the least value, okay? And the least value is what's ever in the y position, and that's negative 3. So we've got a lot of new terms and lingo to look at as we go through and learn how to graph these parabolas. Now, if you notice again, Mrs. Burton said that this parabola goes up. And the reason it goes up is because what's ever in front, if x squared is positive, then my parabola goes up. So let's go to the next slide. Let's go ahead and graph this one. Now I'm going to help you a little bit. We're running out of time. So let's go ahead and fill in my chart. If we went through and did the math, this is what we would find. We would get negative 6 when we plugged in negative 2, negative 1. When we plugged in 0, we would get a 2. When we plugged in 1, we got a 3. 2 was 2. This is negative 1 and negative 6. All right? So basically, I filled in the input-output chart, but you would have had to gone through and fill in, calculate the y's for each one of those x's. Now, did you notice this time? What's in front of a? What's in front of x squared? I don't want this one, okay? What's in front of x squared? I want this one. In front of x squared, we have a negative sign. So we're going to find out when x squared is negative, then my parabola is going to go down. So let's go ahead and put our grid marks on here. Get your graph paper ready. and we're going to graph this parabola. Okay, we're going to graph the parabola. So let's go through here and look. We're at -2, -6, 4, 5, -2, -6, which is down here. We're at -1, -1. We're at 0, 2. We're at 1, 3. We've got 2, 2, which puts me about right there. 3, -1. And then we're at 4, -6. So I'm back down here. If we connect the dots, what happens? This time we have an upside down U. Okay? So since my parabola went down, what's my highest point? Well, the highest point this time is right here, and we're not going to call it the minimum this time. What are we going to call it? Yeah, we're going to call it the maximum. Okay? Okay, and the maximum is 1, 3, and once again, that's the vertex. So once you find the maximum, that upper point, and you know it's your vertex, then we know our axis of symmetry. Remember, the axis of symmetry is the vertical line that goes through my vertex, so it's right there. And so that's going to be x equals, what was in the x position? A 1. And instead of calling it the least value, this time it's going to be the greatest value. And what's in the y position? 3. All right, so we've got to kind of get some general rules here as we go through and look at this idea of graphing parabola. So let's see if we can do my fill-ins on the next slide. Okay, so this equation, f of x equals ax squared plus bx plus c, should look very familiar from chapter 5 land. Remember, that's a quadratic function. As soon as we see that I've got x squared, then we know it's quadratic. Now, we're used to noticing x squared and say, oh, I know how to factor that, I'm going to x factor, but we're actually graphing now. Okay, we're graphing, we're not factoring. So if the domain of my function f is the set of all real numbers, then my graph is that U-shaped graph. And what did we call that? Yeah, that graph is called a parabola. We saw that if a is positive, if whatever in front of x squared is positive, then my parabola goes upward. That was the first graph we did. If a is negative, that was the second graph. If you remember, we had negative x squared, then the parabola goes down. Now, here it is. The x-coordinate of the vertex of the parabola is an equation, the opposite of b over 2a. To find the axis of symmetry, then, you have to memorize that equation. X equals the opposite of b over 2a. Now, where do you think that b is coming from? Yeah, back up here. There's b. It's in front of my linear term. And that a is coming from what's in front of x squared. Okay, so very important pieces of information as we go through. Now, so if you look at one of your homework problems tonight, it says, all right, homework says, find the coordinates of the vertex, then give the equation of the axis of symmetry and the least value of the function. Well, what we need to do first, okay, is we have to find the axis of symmetry. Once we find the axis of symmetry, then we can go ahead and find the coordinates of the vertex. And once we know the coordinates, then we can find the least value. So when I'm looking here at this problem to take care of it, the first thing that's real important that we do is we make sure that my quadratic equation is in standard form. So let's look at that function. We've got g of x, and it says 9x squared minus 4. Now, is that in standard form? Well, yeah. Did you notice something's missing, though? What's missing? Yeah, that linear term's missing in the middle. So it might be helpful if you look at my first little bullet point here, it might be helpful to rewrite it. Make sure it's in standard form. So we're going to say y equals 9x squared. Now, you notice the linear term's missing, so I'm just going to go ahead and say plus 0x minus 4. Now that we've done that, we know that 9 is A and 0 is B. So the next thing we need to do is we need to find the x-coordinate. Well, remember, that's a formula. X equals the opposite of B over 2A. So let's go over here. If I'm trying to find the x-coordinate, well, here we go. X equals the opposite. What did we say B was in this equation? Yeah, B is 0 over 2A. What's A? 9. So we've got negative 0 over 18. But guys, what's 0 divided by 18? 0. Okay, so x equals 0, okay, is my axis of symmetry, okay? That's the equation for my axis of symmetry. Since it's a vertical line, it's got to be x equals, okay? Well, now that we've got the axis of symmetry, we're going to take that x and we're going to plug it into the original equation to find my y coordinate. So we're going to get 9 times 0 squared minus 4. Okay, we just plugged it back into the original. Well, that's going to give me 0 minus 4, so y equals 4. Negative 4, I'm sorry. Okay, so that's my y coordinate. Okay, and so now I know that the vertex is my x coordinate, which was 0, and my y coordinate, which was negative 4. And then how do I find the least value? Well, it's whatever was in the y position. So that was negative 4. Now, as we go through here, Mrs. Burton, you know me, I have a handy-dandy little honey-do list for how to graph parabolas. So let's quickly write this up here, and then I'm going to let you start your homework. Okay? So this is the honey-do list to graph parabolas. Okay, and again, it's got to be in standard form. Y equals what? AX squared plus BX plus C. All right, now the first thing I like to do is I like to decide whether it goes up or down. And again, that's where we're looking at A. If it's positive, it goes up. If it's negative, it goes down. The second thing we need to do is we need to find the x-coordinate. So when I go to find the x-coordinate, we have that formula memorized. X equals the opposite of B over 2A. After we find the x-coordinate, we're going to plug that x in and find the y-coordinate. Okay, so we just plug it in and do the math. Plug it in and do the math, and we're going to get the y-coordinate. Now, when we find the y-coordinate, we've also found our least value. Okay, so we're going to find the vertex then. To find the vertex, remember, it's an ordered pair. We're going to put the x from number 2 with the y from step number 3, and that is my vertex. Once I know the vertex, I know my axis of symmetry. Remember, my axis of symmetry is x equals, okay, x equals what's ever in the x position. All right, and then after that, we have to graph. We have to graph some points. Now, we use an input-output chart. And Mrs. Burton will show you tomorrow how I use the idea of mirror points because of that axis of symmetry. All right, so I'm going to let you go ahead and start homework, and we'll try this again tomorrow.